We have learned how to solve right triangles, and one of the reasons we need to understand that concept is to use an application called angles of elevation or angles of depression. An angle of elevation is an angle that occurs when the line of sight is above the horizontal. An angle of depression is the angle that occurs when the line of sight is below the horizontal. On example 8, we are given that a 14-foot ladder leans against the side of a house. The top of the ladder is 12 feet off of the ground. We are asked to find x, the angle of elevation of the ladder, and we are told to round our answer to the 10th. The first thing I want you to see is how here's angle x, and notice that when they're talking about the angle of elevation, here's the horizontal, and it's the angle from the horizontal. It's always important to remember that both angle of elevation and depression are from the horizontal. Our picture is given to us and shows exactly how everything should be set up. And so all we have to determine is what relationship we have in this picture. The 12 is the leg across from x, so it's the opposite. The 14 is the hypotenuse, and so the function that uses opposite and hypotenuse is sine. So the sine of x has to equal 12 over 14. Now remember, anytime you want to find the angle measure, you have to use the inverse trig function. So x equals the inverse sine of 12 divided by 14. Put this into your calculator, you get 58.997. And if you have to round that, then that's going to round to be 59 degrees. On example 9, we are asked to find x, which is the angle of depression, from the top of a lighthouse that is 165 feet above the level of the water line of a ship that is 941 feet off of the shore. And again, we are told to round our answers to the 10th. And you will find that in ALEKS, they give you the pictures, so you just need to determine what function you need to use. If we look at our angle, here's x, and then looking at the two sides we are given, the 941 is the leg connected to x, so it's the adjacent, and the 165 is the side across from x, so it's the opposite. If we know opposite and adjacent, then we need to do the tangent. So the tangent of angle x will equal the opposite of 165 over the adjacent of 941. Anytime you need to find the angle, you use the inverse function of 165 over 941. And putting that into your calculator and rounding to the 10th, you will get 9.9 degrees. For example 10, I wanted you to see a problem where the picture is not given to you and how you would figure out where the angle of elevation or depression is. So in example 10, we have an airplane is flying above the ocean with an altimeter. An altimeter tells you your altitude, indicating an altitude of 10,000 feet above the ocean. The pilot observes that the angle of depression to a ship is 20 degrees. What is the horizontal distance from the ship to a spot directly below the airplane? So like many application problems, the first thing that you need to do is draw yourself a picture. Do not laugh at my artwork. So I've got this airplane. Just pretend this is beautiful. And we know that the airplane is 10,000 feet above the ocean. The altitude is 10,000 feet. Down here, we've got our ocean. Over here, we've got a boat. We are told that the angle of depression, now remember, angle of depression is from the horizontal, so it's really helpful to draw yourself a horizontal first. Here's your horizontal. The angle of depression to the ship. So our angle of depression is going this way to the ship. That means that the angle we are talking about from the horizontal is out here. That's the angle measure that they have told us. And that angle measure is 20 degrees. The thing is that we know that these two have to be 90 degrees. So if this outside angle is 20 degrees, then the inside angle has to be 70 degrees. We are looking for the horizontal distance from the boat to right below the airplane. So there's what we are looking for. If you look at the relationships that we have inside the triangle, the angle we're using is 70. The x is the opposite, and the 10,000 is the adjacent. So that means we need to do tangent. Tangent of 70 equals the opposite, which is what we're looking for, over the adjacent, which is 10,000. To solve this, we would need to multiply both sides by 10,000. So x is going to equal 10,000 times the tangent of 70. And if you do that on your calculator and round to the 10th, you should get 27,474.8 feet.